Welcome to another of my videos where I work through and explain A-level physics multi-choice questions. If you want to try to answer this question yourself, please pause the video now. If you got the answer D, well done. If you'd like to hear my explanation of how I found the answer, please continue watching. So an experiment is carried out to determine the Young modulus E of steel using a vertical wire of initial length L and cross-sectional area A. Various weights are suspended from the wire. A graph of extension against weight is plotted. What does the gradient of the graph represent? So let's first of all remind ourselves what the Young modulus is equal to. The Young modulus is equal to the tensile stress divided by the tensile strain. And stress, or tensile stress, is given by the force on a wire over its cross-sectional area, and the strain is given by the extension of the wire over its original length. I can substitute these for stress over strain in my original equation, and I find that the Young modulus is equal to the force multiplied by the original length over the area and the extension. Now we're trying to find the gradient of the graph, and I've got a straight line graph, and straight line graphs are always of the form y equals mx plus c. And we can see that what the extension is on the y-axis. So I want to make this equation in the form of a straight line equation where y, or the subject of the equation, is the extension, which is delta L. So I'm going to rearrange the equation. Delta L is equal to the force multiplied by length over the Young modulus and area. Now let's remind ourselves the weight is the force in this particular case. So my delta L is y, my force is the x, which leaves L over EA, or the original length over the Young modulus and the area, equal to the gradient. So my gradient is L over EA. Answer D. If you found this video useful, do press the like button. Any comments will be welcome. Perhaps you'd like me to look at a particular question, and I hope you'll share this video and watch more in the series.